So now that we got introduced to a concept of a topic, one of the central elements of Apache Kafka story, let's move on and add two new concepts, brokers and partitions. I already mentioned that Kafka cluster consists of multiple servers, and these servers are called brokers. And topics are supposed to be stored on these brokers. And the topic, as you can imagine, can have millions and possibly trillions of events because we persistently store the data, so it can grow pretty big. So we need to think about how we are going to store these huge topics on the servers. And now, remember, in one of the past videos of this series, I mentioned that a topic is an abstract term. The topic itself is not a physical, tangible thing stored as a whole on single server. It's probably neither reasonable nor feasible to keep a topic as a single piece of data on a single machine. Very probable that one day the size of the topic will outgrow the server's memory, so we need a strategy to scale horizontally and not vertically. And to achieve this, we do something smart. We split the topic into multiple chunks that will be stored across multiple machines. And these chunks we call partitions. Each of these partitions is technically a log of messages. Some of you might be already familiar with the log structure, but if you are not, it's pretty simple type of storage. It is append-only sequence of records ordered by time. So it's a file and we write to the end of the file. And these logs, or we will be calling them partitions, are stored on the brokers, on the disk storage of the brokers. Partitions are independent, self-sufficient entities. Each partition will maintain sequence number for their own values. It's quite important. Each partition will maintain sequence number for their own values. So the offsets we mentioned before, those numbers of the messages, have only meaning within a single partition. This means that the numbering of the items on the screen right now is technically incorrect. Instead, each partition will have its own count, and let's fix it. So now you can see that each partition has of item with offset number 1, 2, and 3, and each of them will have the same offsets. But the items are different. And this is how distributed systems work. We divide the load across partitions and conquer it independently, and later we merge the results back. So when I was saying in the past that a producer writes to a topic, what I meant is that a producer writes to a set of partitions and the consumer later reads from a set of partitions. Behind the scenes, our consumers and our producers know quite well how to work with multiple partitions, so you don't have to worry about durable messaging or concurrent distributed transactions. However, we will have some challenge on our plate as well. And the spoiler alert, the biggest challenge is related to the ordering of the messages. So now that we realize that offset is only reliable within a single partition, how exactly we order the messages, how we live with this? And in some cases, you would need to guarantee that the ordering of the messages that is read by a consumer is the same as they were sent by the producer. But due to the distributed nature of Apache Kafka, this isn't always the case, and it is by design. So to understand what is happening, let's see how the producer is spreading the messages across partitions. Here I have a sequence of messages and I have 3 partitions in a topic. In the most simple scenario, where we are using a default partitioner, and don't provide any extra information, the items will be distributed across the 3 partitions in a way where we cannot really predict which message will go to which partition. This animation is a bit overly simplified, but for now it's important to understand that a partitioner will distribute the messages as efficiently as it can without specifically directing where the data goes. Unless, of course, and we will later see it, we give the partitioner some extra details. But assuming we don't do any extra details, let's think how information then will be read by the consumers from this partition. So consumer will have to bring this data somehow from these separate partitions. And when consumer reads the data in a similar way to the producer, we cannot guarantee from which partition consumer will start reading, nor we cannot guarantee the sequence of partitions. Also, maybe some of the servers go down, so consumer can't read it from partition 3. It will consume the data later. It will first consume the data from partition 2. This is part of a distributed system. They are fast, but certain trade-offs need to be there to process data in parallel. So by the time you are getting the data on the consumer side, the order of messages will be reshuffled comparing to how it was initially written by the producer. And this is kind of normal and might be fine for plenty of scenarios, but not good for other use cases. So how do we live with this? Apache Kafka can guarantee the order within a single partition. As we discussed, a partition is technically a log file, so it's a long log file with items written one after another. And if we write all the items, the order of which is important for us, into a single file, by the nature of a single log file, we preserve the ordering. And for us, for example, the ordering of messages related to a single shopping trip made by a customer is quite important. Logical sequence of events that the customer first will add the item to the basket, then the customer will do the payment, and then we deliver the item. If the ordering of those events for a single customer is messed up, our system becomes unreliable and, to be honestly, quite useless. To guarantee that the ordering for every customer is correct, we'll split the messages across the partitions in a way the data related to each customer will get always exactly to the same partition, to the same log file. And the most convenient way to do this is with the help of the key. So far, our messages consisted of some message body. But we can also add a key for every message. And key plays a dramatic role in how messages are distributed across partitions, because all messages with the same key will be added to the same partition. So let's look at this example, where we have a specific topic with product purchase lifecycle. And we have some actions performed by the folks as well as other customers that we have. So the folks first searched for an item, and they added the item to the basket and finally ordered it. And we set the key for each message equal to the customer ID. Again, this is a bit overly simplified situation, however, just to show you how to use the key. So the key is a customer, and the body of the message itself is a customer action. Behind the key, Apache Kafka will do some math and some calculation and will decide to which partition to write data with the fox. And later, all the items with the fox will always go to the same partition, and the same for the other customers that we have. So in a way, this distributed the items that all the information for the fox and for the cat got into the first partition, piggy information went into the second, and the last one contains information with the bunny. You can see that partition doesn't have to store one single key, because most probably we will have plenty of keys in the system, so we can't really dedicate a partition per key, and most probably it's not wise to do so. So it will be a mixture of different customers using the same partition. And now that we need to read the data, we can be sure that the ordering of the records for every separate customer will be preserved. So it's for every individual customer. The ordering across the customers most probably will be not correct. However, we also might not care about that. And this is an introduction to partitions and keys in Apache Kafka. Leave any questions or comments you have in the comment section below, and if you enjoyed the video, please like it and subscribe to the channel.